Hello, in this presentation, we will show you the diabetic retinopathy classification using vision transformer. This presentation is by Dr. Abdullah Al-Mutawa from Computer Engineering at Kuwait University. And the project is funded by Kuwait University Research Administration. In this presentation, we will start with the introduction, then the research objectives, followed by literature review, then methodology, results, and finally the conclusion and recommendation. As an introduction, a disorder known as diabetic retinopathy, DR, I'm going to refer to it in this presentation, affects the eyes and is brought on by high blood glucose level, which harm the retina's nerves and blood vessels. 1 in 3 people, statistics shows that has diabetes with retinopathy that are eventually, if not treated well, they might lose their sight. In statistics shows that from 2000 to 2019, the mortality increased by 3% based on the age, and according to World Health Organization, WHO, the statistics is also increasing even after Corona. The vision may be affected and it may even result in blindness if it is not treated well. Early detection of and controlling this would change the result dramatically. Our research objectives is to classify the DR stages using the vision transformer, VIT, and convolution neural network, CNN, using deep learning model with different optimization. Different stages as seen in this images here. This is where the retina is normal. This is mid, moderate, severe, and very severe. It's when it's more than 15, the time frame for the DR in years. And these are the changes, and so our system will categorize based on the image given. In the literature, many research has worked in detecting the DR regarding from fundus images by applying several transform. Some research showed that with data augmentation and pre-processing method, this could be accurate as 75%. Some papers in the literature used CNN with augmented other transformation and tools. In our system here, we implemented as shown in this methodology into the 4 main steps. Step 1 is the data selection, and step 2 is the pre-processing. Step 3, model selection. Step 4 is deep learning model and classification. And we use in this model the virtual mode to do the architecture transformer. We split the image into patches. We flatten the image patches, create lower dimensional linear embeddings, and then include the positional embedments we feed this sequence into the transformer encoder, and we pre-train the VIT model with image labels. Model evaluation from the image and classification. The CNN model is as shown here. The first two layers of the convolution layer, which perform the feature extraction, then the pooling procedure. We do then the maps pool layer by presenting the crucial character of the image. We have some dropout layer is applied also, and finally it's fed into the layer and then full connected layer. As a result, we use the ADAM, adaptive mode estimation, and follow the regularized leader FTRL, and then the NADAM with the parameter as shown here. With this evaluation metric, the accuracy, precision, and recall, and the F1 score is given by these equations here. And we got these results here for each and every parameter, different optimization test data, and the training and validation accuracy, as we can see here, with the first 35 epochs, and the training and validation and loss, comparing the trained and validation data for the loss as shown in this figure. And these are for repeatedly for different accuracy, and we tested for 60 epochs, and setting up the parameters here, and these tables are the results. We concluded that using all different parameters, use the transform-based deep learning model, categorizing stages of DR. We also compared the VIT model with the state-of-art CNN model. The finding demonstrated that the VIT model is better, predicts the DR classification than the CNN. Best model with the ADAM optimizer accuracy 75%, F1 score is 73%, precision is 71.5%, recall is 76%. Grading the severity of DR is a crucial step to aid every identification, treatment, and halt the disease program. And so this concludes our result of the best gotten. And finally, this is the recommendation here. Pre-processing the input using the pre-trained model layer, applying the model based on large data available publicly, and comparing the model with different transformer model. And this concludes the presentation, and thank you for your follow. Hopefully, if any questions, we'll be happy to answer through the channels available.